It's almost 7:15, so we'll get started. In terms of announcements, next week will be our last meeting. We're going to do Hacker Jeopardy. We will get pizza, so we may send out a survey for that in terms of how much we should get. We're also doing cabinet elections next week. So all positions are up for re-election/election. So if you're interested in any of those, all you have to do is show up and let us know you're interested. If there's more than one person that wants that role, then we'll just do a little speech or something and then take a quick vote. So that'll go down, Hacker Jeopardy, we'll do pizza. Yes, Keane?
Can I interject regarding the elections? If you want to know what each position is and what the responsibilities are, the Constitution is linked somewhere in Slack. We can always repost it as well. So
yeah, it's on the student org website too.
Right, that's it, yeah.
So, and then if you have any further questions about that, just let us know in Slack. I think that's about it. That'll be our last meeting for the semester, so just be aware of that. And then I'll send out details on when and where. It should be the same 3043 next week. For this week, we've got Brandon here who's going to be talking about air gap systems. And then after, we'll work on a CTF if you guys want to stick around. And we'll go from there. So I'll hand it off to Brandon.
All right. So my name is Brian Evans. I'm presenting on air gap systems. Just let me get the keyboard out here so I can. All right, disclaimer, I am not an info security expert. I am a mathematician who just found this interesting. So what are air gap networks? Air gap networks is a network security measure employed on one or more computers and that ensure that a computer network is physically isolated from an unsecured network such as a public internet and local area networks. So you can imagine like your public area network and your private air gap network just completely isolated. So think of like basically a cloud and the ground. It's isolated until it's raining, and of course you don't want it to rain. Air gap networks are separated by levels of classified information. So you have your high side, which correlates to your highly classified information. So your government secrets, your hit lists, what have you. And then while you have your low side, which is less classified information, so your financial documents, people who get paid, things like that, for example. We have to, in air gap network systems, we have to separate this kind of information from the public, from getting hacked into. So once the system is physically isolated, everything within the system has to be physically isolated. So physical isolation within physical isolation. This will include Faraday cages, distance separation, and complicated ways of moving classified pieces of information toward unclassified or vice versa. So think about how we exchange. So in the event of nuclear war, where we have to launch nuclear missiles, president sends a string of code which two people in a very small room have to solve, a very small room that's physically isolated from all other systems, all other networks, and then they have to both turn the key. So you have your Faraday cages, distance separation, moving pieces of classified information from high side to low side within a medium of transport such as a USB. And in this sense, in this case, the high to low, oops, I messed that up. No, high to low is minimal while the process is very complicated from low to high. I mean, getting information, if a hacker got information that was going from high to low, no one would pay attention, but if it's going from low to high, that can be very complicated in the process. It can be very complicated. Who uses these air gap networks? So military organizations, SCADA security systems, Stock market financial computers, you don't want anyone getting into that. Industrial control systems, life control systems such as nuclear power plants and electrical power plants, hydropower plants, and little bit of a note, actually a lot of these systems are no longer sufficiently air-gapped. They do now rely on public internet and Wi-Fi, and that's why you can find a lot of SCADA networks and industrial control systems on websites like Shodan.io. Okay, a little bit of history. There were air-gapped network hacks before Dr. Van Eck, but Van Eck and his method, which we now call Van Eck freaking, he's the one who made this all popular, and it's now in pop culture. You'll find it everywhere because of him. You'll find it in shows like Numbers, like Castle, and other really neat shows. So Van Eck freaking is the act of exploiting electronic devices via receival of EM emissions that can be used to exfiltrate data from the device. An example, by exploiting oscillating currents on video display, we can actually recover the image on the screen being displayed. So the image that's being displayed up here, coming from this, can actually be displayed on anyone's computer if you so chose to beam some kind of RF beam at it. You can actually recover it through through a little bit of finagling with some data recovery algorithms. You can do that. You can recover the image being displayed thanks to EM radiation and radio emissions. So, fix that. This is wrong. I'm very sorry I put this. Not all air gap hacks are in this form, but a lot of the very popular ones are, and I'll show you those in a second. This type of exploitation was used to compromise the secrecy of electronic voting systems in both Brazil and in the Netherlands. This is a proof of concept, and it can be read. This was pioneered by Dutch physicist Dr. Van Eck in 1985, I believe. Okay, so first, while this is not the first instance of an air gap hack, this is simply the most prominent. This was discovered by the conspiracy lab. Everyone remembers the Stuxnet virus, right? Discovered in 2010 by Kaspersky Lab. The Stuxnet virus targeted Iran Simian SCADA systems, and what it did was it caused damage to the Iran's nuclear program, as we all know. It spread via Microsoft Windows systems and Simian systems in the PCSM industrial software, and we compromised it via USB. I say we because that is not a secret that we did that. It's not necessarily confirmed, however, everyone thinks so. Everyone thinks that we did it. It was a joint task with us and I believe is the Israelis, if I am correct. Oh yes, it was. Designed to force excessive vibrations by raising and lowering the speed of targeted centrifuges. Basically, we just mess with their centrifuges, and it's like, turning a light on and off again until it explodes. All right, another instance of the air gap hacking, Brutal Kangaroo, which was published in WikiLeaks, and it was developed by CIA security analysts, and it is a tool for targeting closed networks by air gap jumping using thumb drives. So in most, if not all instances in air gap hacking, the virus must be placed there physically by someone, and then they do the air gap hack. So this is a tool suite for targeting closed network systems by air gap jumping using thumb drives. The Brutal Kangaroo components create a custom covert network within the target closed network. So it provides functionality for executing surveys, direct listings, and arbitrary executables, consisting of the following components: the thumb drive itself, the servo tool that handles the automatic infection of thumb drives, primarily It's primarily a mode of propagation, and the post processor, I believe I'm not necessarily to terms with what post processor means. I believe that's the 5th step or 4th step in a hack. Is that right? The 4th step in a hack is keeping, a window open so you can do what you need to do. And a persistence tool that creates a covert command and control network inside the closed network. Okay. Oops. Nope. All right. This one was very interesting, and this is the, I didn't get a chance because I didn't have the materials. And but this is the demonstration I would have done for you guys. Researchers developed a unique way to utilize hard drive LEDs. So like the ones you have in PCs, the ones they're all around the school here. Use that hard drive LED in a drone to exfiltrate hard drive data. I will show that to you in. This will be the last thing I show. Come on. All right. Bad USB. This was a really interesting air gap hack because this is interesting because it solely relied on software. You'd put it in and you literally don't have to do anything else. So this operates solely off of software, which is not many things do that. You don't need a lot of hardware like a drone or an RF antenna. This operated solely off of software, and it was emphasized in the research article because it did not involve any hardware or firmware changes to execute an attack. It's short-range data exfiltration using EM emissions from a USB dongle. So essentially, you have the USB port, and a lot of electromagnetic radiation comes from that. So coming from the coil inside the computer, going to the USB dongle, it reads all that. So it's like your hard drive is holding up a giant sign that's giving all your passwords and giving all your encryption keys and all that, and all your data. It's just holding up a giant sign for it. And the USB port is used as an RF transmitter by modulating the data fed at high speed to plugged in devices. So anything else that is plugged in to, I believe, your computer, it'll also read all that data, I believe. So what it's going to do is sends a string of 0 bits to USB port that makes the device generate detectable emissions between 240 megahertz and 480 megahertz. Encodes useful data when a hacker sends a string of 0s and 1s through the USB port, and it can only encode small-sized files such as keys and passwords. The other air gap hacks include the disk filtration, the bit whisperer, the air hopper, the fan smitter, and the GS mem attack. Okay. So how can we prevent these from happening? We do have certain limitations that we need to use inside of government buildings like NSA, CIA, and NASA. We have to have a certain distance and a certain amount of noise going through a lot of systems, a lot of hardware, to prevent any data from being exfiltrated, because noise helps obfuscate the data being expelled by your hard drive or your thermostat or any other hard drive, any other hardware device that you have in your building, your system, anything. Does everyone remember the Mr. Robot hack? How he used the thermostat? This is why we have that distance. This is why we have those things covered by lock and key and everything, because of hacks like that. Hacks like that can actually happen. we have to prevent people from doing it remotely. So we have certain covers on thermostats, and we have a certain bit of distance between the walls and those hardware devices, and we have them separate from. We have them separate from, you know, other things like our computers. So limitations such as restricting usage of certain devices to prevent the spread of malware. Organizations may not allow the usage of USB devices or the use of cell phones with a camera function or the use of cell phones, period. Certainly because of, like, you know, if you bring a cell phone into a building, I don't know if you guys have read in the news, but there is a hack, there is an air gap hack that can, if you put your phone down next to a keyboard, it can read all the plain text it can read all the plain text in vibrations, which I find crazy. I mean, I feel like I want to put on a tinfoil hat after, you know, reading things like that. We want to prevent the leakage of electromagnetic radiation with Faraday cages. And again, in Mr. I'm sorry, this is my favorite show. And Mr. Robot, where he went into that episode we went to the Faraday cage with White Rose. They have that there, so no one's gonna, you know, air gap hack them, or, you know, insert a USB device and then air gap hack, because they have to obfuscate all that noise. Implementing random noise, obfuscating hardware device noise transmission, and banning the use of Wi-Fi entirely. So like Wi-Fi hotspots not allowed in a, you know, a highly secure building with an air gap network. Conclusion: air gapping is efficient depending on the device limitations and overall information security. However, there are still problems in the complication of moving classified information, and there's the problem of, you know, educating your staff, your military personnel, whoever's in the building, whoever's operating the air gap network systems. Therefore it's very fragile. It relies on good security policy enforcement. It's very process oriented, and the process for protecting information in air gap systems can become very, very complicated. And even with good implementation, air gap network systems can still be hacked, unfortunately. So here's some fun reads / references that I used. And I want to go back for a second and show you that drone hack because it's really, really cool. Is it here? No, it's not. There we go. And the little tiny hard drive of that PC should be right around there. If anyone can see that tiny blinking light, what they did, they exfiltrated via hard drive LED signals, and they have hardware on that drone that is going to read those LED signals and transmit malware back to it. But, as everyone knows, the seed, as I want to call it, the seed of that malware has to be implanted in the device first. So, but this is a proof of concept. So say you have an angry employee, like, oh, I want to get back at my boss, so I'm going to, you know, exfiltrate all his hard drive data and do nasty stuff to frame him. But yeah, exfiltrates the data, and then voila. Now you have malware in that computer that can now spread. And I believe that is that. Yep. Right? I'm done.